Hi guys, this is Gopika here and I'm back with my next video, and in this video we'll see few solved examples, okay? And this solved example is based on all those theorems that we learned, that is basic proportionality theorem or angle bisector theorem, their converse, and the property of parallel lines and their transverses, okay? All those theorems, the statements of those theorems and their converse part of them we will use in few sums so that we get how to apply those theorems, okay? So without wasting time, let's get started. Okay, so let's see the first example. So first let's read the question. In triangle ABC, DE is parallel to BC. Okay, in this triangle, DE is parallel to BC. So when you read the first line, the first thing that comes to your mind is basic proportionality theorem. We have a line which is across the two sides and which is parallel to the third side of the triangle. And certainly here we can apply the basic proportionality theorem. Okay, now let's see what we need to find first. If DB is 5.4, so DB is 5.4, AD is 1.8, EC is 7.2, we need to find AE. By basic proportionality theorem, AD upon DB is equal to AE upon EC. These three values we already have. We can find AE very easily. Okay. So first is in triangle ABCD is parallel to BC. Therefore, AD upon DB is equal to AE upon EC. The reason is basic proportionality theorem. Therefore, 1.8. We substitute the values. AD is 1.8, DB is 5.4, EC is 7.2. And AE is what we have to find. Now we can multiply the denominators to the other side. So AE into 5.4 is equal to 1.8 into 7.2. Now divide by 5.4 on both the sides. From here 5.4 will get cancelled and only AE remains. And in this part 5.4 gets divided. Okay. So when you have an equality and you divide both the sides by same number, again the equality remains. Okay. So now this is very simple operation, or very simple calculation I can say. So you just divide and then you'll get the answer 2.4. Okay. So if you see 18 and 54, if I ignore the decimal point, then 18 3s are 54. So if I cancel this, then here I'll get 1 and here I should get 0.3. Okay. And 0.7.2 upon 0.3 is 2.4. Okay. So that calculation you do according to yours. It's very simple. You're in 10th and you're supposed to know all this. The important part is which theorem you apply. Okay, and in the reason you have to mention the name of the theorem. Okay, otherwise you lose marks. So this is the important part. So if you don't mention it, it's not worth solving. Okay, so AE is 2.4 cm. Simple. Now let's move on to the next example. Okay, so in triangle PQR, segment RS bisects angle R. If PR is 15, RQ is 20, PS is 12, then find SQ. Okay, now here you have an angle bisector. So we are using the angle bisector property of a triangle over here. Okay, so you remember the theorem? When you have a triangle and an angle bisector RS, then this angle bisector cuts the opposite side in same ratio of the other two sides. That is RP upon RQ is same as PS upon SQ. Okay. So in triangle PRQ, segment RS bisects angle R. Therefore, PR upon RQ is equal to PS upon SQ. Okay. The reason is property of angle bisector of a triangle. Okay. Write it completely. Just don't stop here. Just mention of a triangle also, because there are other properties of angle bisector as well. So writing it completely will help you out. So now PR is 15, RQ is 20, PS is 12, and upon SQ, just substituting the values, and then you multiply the denominator to the other side. So SQ here and 20 goes there, and dividing by 15 on both the sides. Here they have skipped one step. You can add that step in between according to your convenience. Therefore, SQ is equal to 12 into 20 upon 15. Okay. So if I divide 15 and 20 by 5, then here I get 3, and in the numerator I will get 4. Now 3 and 12 if I cancel, then 3 1s are 3, 3 4s are 12. So 4 into 4, 16. So SQ is 16. The very simple calculation, you should try it out yourself. Okay. First you can cancel and then you can multiply, or you can multiply and then you can divide. Okay. Anything is fine. Therefore SQ is 16. Here they have not mentioned any, so you just write 16. Okay. So we found out the length of SQ. Okay. Simple. So here we have applied the angle bisector property of a triangle. Now let's see the next example. Okay. Now here they have given an activity. The figure is, from the figure you can make out, here we are going to use the property of parallel lines. Okay. And their transversals. The property in which we saw how the intercepts are formed, or how the ratio, what is the ratio of the intercepts and how they are related. So that property we are going to use over here. So we have three parallel lines, that is AB parallel to CD parallel to EF. All these three are parallel lines. AC is 5.4, AC is 5.4, CE is 9, BD is 7.5, and we need to find DF. Okay. So when you have three parallel lines and two transversals, then we can say it is similar to the basic proportionality theorem. Okay. So AC upon CE is equal to BD upon DF. That is what the property says. When you have three parallel lines and two transversals, the intercepts formed are in same ratio. Okay. AC upon CE is equal to BD upon DF. So solution, AB is parallel to CD is parallel to EF. Therefore, AC upon CE is equal to, that is AC upon CE is equal to BD upon DF. Okay. So here this part they have kept it as fill in the blanks. Okay. Fill in the boxes, so that you have supposed to fill. So if you want to fill it by yourself, pause the video and solve the problem with reasoning and then check on my video. Okay. So AC upon CE is equal to BD upon DF. Now we need to mention the reason also. The reason is the property of ratio of the intercepts made on transversals by three parallel lines. This is the reason. Okay. Because the ratio is same. Now we just substitute the values. AC is 5.4, CE is 9, BD is 7.5. Alright. And DF is what that we have to find. Okay. So the next step would be, now 5.4 upon 9 is 0.6, because 9 6 are 54. Remember? But now we need a decimal point. From the left you put one decimal point, so that would be 0.6. Okay. So 0.6 is equal to 7.5 upon DF. Next step would be DF is equal to 7.5 upon 0.6. So DF went this side and 0.6 came this side. So DF is equal to 7.5 upon 0.6, and that is same as 12.5. Okay. So the calculation is very simple. So the main thing is what theorem or what property you are substituting, and accordingly the steps follow. Okay. Therefore DF is equal to 12.5. Okay. So this activity was also very simple. Okay. Okay. So here is the next activity. So let's start. Okay. Before that, I'll choose a laser. Okay. In triangle ABC, ray BD bisects angle ABC. Ray BD bisects angle ABC. Okay. So in the diagram only it is evident. ADC, okay, this A dash D dash C means ADC are collinear points and D is lying between A and C. That is what this means. Side DE is parallel to BC. AEB means again E is lying between A and B and all three points are collinear. Then prove that AB upon BC is equal to AE upon EB. So what we need to prove is AB upon BC is equal to AE upon EB. Okay. So here we apply both the theorems, that is basic proportionality theorem also and then angle bisector theorem also. And when you apply both and match and compare both the equations, then you arrive at this ratio very easily. So let's start. In triangle ABC, ray BD bisects angle B. Therefore, by angle bisector theorem of a triangle, we can say AB upon BC is equal to AD upon DC. So this is the bisector. The angle bisector theorem says that if you have bisector of an angle, then it divides the opposite side in same ratio of the other two sides. So AB upon AC is same as AD upon DC. This is our first point. Next, in triangle ABC, DE is parallel to BC. Therefore, by basic proportionality theorem, we can say AE upon EB is equal to AD upon DC. Now this part they have already given the second point. We just need to fill the reason. So the reason is basic proportionality theorem. Okay. Now if you compare the equations, that is equation 1 and equation 2, you will note that AD upon DC is common to both. Okay. So these values has to match. That is AB upon BC is equal to AE upon EB. That is from one hand. Okay, this is what we had to prove. Simple. So actually all these sums and those activities were really simple. We are just applying the theorems. What we need to really remember is the statement of the theorem, or more than remembering, we need to understand the statement of the theorem, and then we just easily remember all those. Okay? So first understand the statement, understand the proof, and understanding the statement is more important because you apply it in your sums or in your exercises. Okay, so if you understand, and then everything is very simple. All right, and remembering the ratios is not a big deal when you understand the statement. All right, so I'm done with this video. Okay guys, thanks for listening to me guys, and please like the video and please share it with your friends. If you're new to the channel, please subscribe the channel, and if you have any queries, please write in the comment section. You can also follow us on Instagram, and you can ask your doubts through Instagram as well, and we will try and respond to you as soon as possible. Okay, now one more thing, we have started a website and I have mentioned the link in the description box. There you can get the video links, and then even you can get the contact. Actually, we have left our contact details as well, and we will also find PDF versions, downloadable versions of many books. Okay, basically the 10th standard and 12th standard textbooks. And if you're interested in higher mathematics, then we have a lot of books regarding algebra, and we can say about linear algebra, differential equations, and a lot of books also we have put links in that website. So to follow the website, please check the description box and have put the link over there. Okay, so thank you guys, please take care and see you soon.